Hey there, pre-cal students. We're starting Unit 9, Graphs, Trig Function Graphs today, and this is kind of a long lesson. I'll make it as quick as I can, okay? So we start off we're graphing sine, f of x equals sine x, graph the function with x as the independent variable, f of x equals sine x is the dependent variable, x can represent an angle or a real number. So it says complete the table. I've already completed the table. If you want to pause and fill in, that's fine. I got these numbers straight off our unit circle. Notice we're using the 6, pi 6, 5 pi 6, 7 pi 6, because those give us a nice number of a half or a negative 1/2. Okay? And so when I graph these, which let me pull this up some, I'm going to start at 0, 0. At pi 6, I'm at 1/2. At pi halves, which is the third line over, I'm at 1. 5 pi 6 back to 1/2, 0, negative 1/2, negative 1, negative 1/2, and back to 0. And then on this side, I've got negative 1/2, negative 1. I know I'm going really quick, but I'm just trying to make this video as quick as I can. So now I'm going to connect these with a smooth curve, as smooth as I can make it here. In fact, I'm going to turn this sideways to do this quicker here. I'll turn it right way up in just a minute. Okay, there we go. Okay, so there is sine x. All right. Now on the back side of this page, the second page, we're going to answer some questions about this. Notice we're going by pi 6 each of these lines, whereas this is 1, and then the top line would be 2 up at the top of the graph. So, set your calculator to radians mode. Enter y1 equals sine x. I've done that. I'm in radians. You can see at the top of the screen here I'm in radians. Then I go to the window, and I'm going to have x min. If I put in negative 2 times pi, negative 2 pi, press enter, it's going to change that to a decimal. So I've already actually set the window. This is positive 2 pi for x max, pi halves for x scale, negative 2, positive 2, and then 1 for my y scale. All right, I'm going to press graph. And so this is my sine function. This is graph of my sine function. This is 0, 0. And then pi, and then 2 pi. To the left, I've got negative pi, negative 2 pi. Okay? Now it says change the window from negative 4 pi to positive 4 pi for our x min and x max. So negative 4 pi and positive 4 pi. And we'll be able to see more of the graph here. What does the graph look like for x greater than 2 pi? So here's 2 pi right there. Here's 0, pi, 2 pi, 3 pi, 4 pi. Notice it just keeps doing the same thing over and over again. So that's what we're going to say. What does the graph look like? Keeps repeating the pattern. Past 2 pi, it keeps repeating the pattern. So starting at x equals 0, the graph completes one complete cycle from 0 to 2 pi. That's one complete cycle. Therefore, the sine function, we call it, this is a periodic function. It has a period of p equals 2 pi. So a period is defined as the length of time or the amount of time before it starts repeating itself. So if I start at 0, 0, it goes through pi to 2 pi, and then it starts repeating. So every 2 pi, it repeats itself. So let's go back to negative 2 pi to positive 2 pi on the window. Negative 2 pi to positive 2 pi. All right, we'll let that draw. And while we answer the following questions for x in this interval from negative 2 pi to positive 2 pi. Number 5, maximum value. The highest I ever get is a positive 1. Where does it reach its maximum value? Well, I reached the maximum value twice between negative 2 pi and positive 2 pi. Each one of these lines on the x-axis is pi halves. So this is negative pi halves, negative 2 pi halves, negative 3 pi halves. I get positive 1. And then positive pi halves, 1 pi half. I get positive 1. Minimum value is negative 1. All right, and I hit that twice. First time is at negative pi halves, and then positive 3 pi halves. The domain, this thing's going to go forever to the left and forever to the right. So from negative infinity to positive infinity. The range is from negative 1 to positive 1, inclusive, including negative and positive 1. So we're putting brackets to show inclusion here. X-intercepts. So I hit the x-axis 1, 2, 3, 4, 5 times. All right, I'm hitting the axis at negative 2 pi 0, negative pi 0, 0, 0, pi 0, 2 pi 0. So pretty clearly, every time I have another integer multiple of pi, I'm going to get a 0. I'm going to get an x-intercept. The y-intercept happens at 0, 0. It's where it crosses the y-axis. F of x, this means that f of x equals sine x is an odd function. It has origin symmetry. You can turn this graph upside down. It looks exactly the same. Okay? What this means literally is that f of negative x equals the negative of f of x. So that also tells us that sine of negative x is the opposite of the sine of x. Okay? And that'll come up later. Okay, let's go to cosine. So at cosine of 0 is 1. I've got 1/2, 0, 1/2, negative 1/2, negative 1, negative 1/2, 0, 1/2, and back to 1. Okay, going the other way, going in a negative direction around the circle, I've got positive 1/2 at negative pi thirds, and then down to 0, and then negative 1/2, negative 1, negative 1/2, 0, 1/2, and back to 1 again. So let's graph this one. So 0, 1, and then at pi thirds, 1/2, 0, negative 1/2, 0, right here, 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 and here. On this side, there, here. Okay, again, I'm going to turn this sideways. And anytime you need to go rewind or pause or whatever you need to do, please feel free to do so. I'm just trying to get through this as quickly as I can while covering everything I need to cover. Okay, there we go. So there's our cosine. That is the graph of cosine. Notice again, pi 6 is each line. We use the multiples of pi thirds, 2 pi thirds, 4 pi thirds, 5 pi thirds, because that's where I got a half value. At pi 6, I get root 3 over 2, which is not nearly as nice a number to graph as 1/2 is. Okay? All right, let's look at the questions here. This graph also is periodic. The periodic is how long it takes to complete one full cycle. Period is p equals how long before it starts repeating itself? Well, I'm at a peak at 0. It goes down and comes back to a peak at 2 pi, so it'll start repeating after 2 pi. So the period, just like sine, cosine has a period of 2 pi. Maximum value is 1. Where does it reach its maximum? Well, at negative 2 pi, at 0, and at 2 pi it reaches its maximum. Minimum is at negative 1. Where does it reach that? That's going to be at negative pi and positive pi. Domain is all real numbers. The range is going to be from negative 1 to positive 1, inclusive. All right? X-intercepts. Let's look at the x-intercepts here. X-intercept at negative 3 pi halves, negative pi halves, 3 pi halves, all those odd pi halves. So negative 3 pi halves, 0, negative pi halves, 0, pi halves, 0. So anytime I have an odd pi half, I'm getting a 0 for my y value. Those are x-intercepts. My y-intercept is at 0, 1. I did that backwards. 0, 1 is my y-intercept. F of x equals cosine is an even function. Okay? This is an even function. What that means is f of negative x equals f of x. So cosine of negative x is going to be the same as cosine of x. All right? These are called sinusoidal functions because they have what we call a sine curve. They have this repeating wave pattern, which is called a sine curve. All right? So that's why this is a sinusoidal function. Last one, graph of tangent. All right? So at 0, I have y over x, that's going to be 0. At pi fourths, I have root 2 over 2 divided by root 2 over 2, which is 1. At pi halves, this is undefined because I'm going to get 1 over 0. 3 pi fourths, I get negative 1. Pi, I have 0. 5 pi fourths, I have positive 1. 3 pi halves, undefined again. 7 pi fourths, negative 1. 2 pi, 0. Negative pi fourths, that would be negative 1. Negative pi halves, that would be undefined. Negative 3 pi fourths, positive 1. 0, negative 1, undefined. This would be positive 1 and 0. So let's graph this. So I'm going to graph this by first putting in all my undefineds as vertical asymptotes. All right, so at pi halves, I've got a vertical asymptote. So I'm going to draw a dashed line at pi halves. Next one is at 3 pi halves, right over here. Negative pi halves, vertical asymptote. Negative 3 pi halves. Okay? So, at 0, I'm at 0. At pi fourths, which is going to be halfway between pi halves and pi fourths, in other words, halfway between pi sixths and pi thirds at this 1.5 space here, I'm going to have positive 1. All right, at negative pi fourths, I have negative 1. And so, well, let me put my points in and then we'll talk about the graph. I have, actually, I want negative 1, not this point. Negative 1, 0, positive 1, negative 1, 0, and I would have positive 1 here. Negative 1, 0, positive 1, 0, positive 1. All right. So what happens is, let me just talk about between these first vertical asymptotes here. As I get close to the left asymptote, it's going to dive down to negative infinity. As I get close to the right one, it's going to go up to positive infinity. So it looks a little bit like a cubic function. All right. Oops, missed one. Okay, so that is the graph of tangent. Okay? So, last page. We're going to set our window y min from negative 4 to positive 4. Negative 4 to positive 4 here. Press graph. Notice on these calculators it does not draw in the asymptotes. On the old calculators it used to connect them and it would have these solid vertical lines in between. But on the new calculators they don't put the asymptotes in. But we have each place, you know, between the going up on the right and going and then down on the left here. That would be a vertical asymptote, vertical asymptote, vertical asymptote here, vertical asymptote here. Okay? So the period, so how long before they repeat here? Notice it starts repeating. I have this little cubic looking thing, and then it starts repeating, right? And that's more often than 2 pi. It repeats between every set of vertical asymptotes, and that's from negative pi halves to positive pi halves, so that is a distance of pi. The period for tangent is only pi. It's half as big as the period for sine or cosine. Vertical asymptotes are at x equals negative 3 pi halves, negative pi halves, positive pi halves, positive 3 pi halves. Domain would be all real numbers except x cannot equal negative 3 pi halves. Well, let's just say this. Let's say odd multiples of pi halves. Okay, odd multiples of pi halves. The range, though, look at your range. Range that goes down forever, goes up forever. So the range is going to be, sorry, couldn't see that really. It goes down forever and up forever. So the range is all real numbers. Range is all real numbers, but the domain is no longer all real numbers. All right, x-intercepts. X-intercepts occur at negative 2 pi, negative pi, 0 pi, 2 pi. So all these multiples of pi. Notice that those are the exact same x-intercepts as sine over here, right? Negative 2 pi, negative 2 pi, negative pi, 0 pi, and 2 pi. Same thing, because sine is your y value, and wherever y is on top, remember tangent is y over x, so whenever y is 0, I'm going to get an x-intercept of 0. And it's going to cross the x-axis. Okay? Y-intercept crosses the y-axis at 0, 0. Okay? Tangent x is a blank function, even or odd. This is an odd function, meaning once again, the tangent of negative x equals the negative of tan of x. All right. That was a lot of stuff. I hope that made sense to you. I know I went quick. If you have questions, let me know. Good luck with the homework. I'm sure you'll do fine with that, and I'll talk to you later. Bye-bye.